So let's start with talking about organizing statistical data. To begin with, there are two types of data in statistics. The first is called categorical data. This is data that can be put into categories. Things like hair color or eye color, or gender or religion. The main thing is that I can group my individuals in my study based on this one particular category. In contrast to that, we have quantitative variables or quantitative data. This is going to be numerical data, things where calculations actually make sense. Things like height or weight or a length of time. So this is our two big groups of variables in data, categorical and quantitative. So when we look at organizing data, we're wanting to talk about graphs and charts and tables. And the ones we use depend on what kind of data we have, categorical or quantitative. So we're going to start by looking at graphs for categorical data. We'll start with what's called a categorical distribution, which is essentially going to be a table for our categorical data. And for our table, we'll need 3 total columns. These are going to be category, count, and percent. So let's look at an example. Let's suppose we have data for several people's favorite color. So here's the data we have. We have this for 16 people between 4 colors, blue, red, yellow, and orange. And we want to build a categorical distribution. So let's start with our 3 columns. For the category column, we're going to list out all of the colors. Now that we have all of our categories listed out, we're going to deal with the count. And the count just counts out how many times that thing is listed. So let's start with blue. And we'll go ahead and move over to a blue pen. So we have 1, 2, 3, 4, 5 blues. For red, we can see 1, 2, 3, 4 reds. For yellow, we have 1, 2, 3 yellows. And for orange, we have 1, 2, 3, 4 oranges. So now that we have our count, finally, we want to find the percent. So we have 16 items. So now we just need to divide everything by 16. 5 divided by 16 as a percent would be 31.25. Four as a percent would be 25. So we can go ahead and fill that in for the orange too. Finally, yellow as a percent would be 18.75%. So we now have our categorical distribution. Now that we've organized the data, let's talk about ways to present it. The first we're going to look at is a pie chart. For a pie chart, we need to start with a circle. And we're essentially going to break this up depending on those percentages from our categorical distribution. So red was 25%. So here's roughly 25% for red. In addition, orange was 25%. So here's orange down here in the other 25. Blue was 31.25, so slightly less than 1/3. And then the last remaining slot would be for yellow. A couple of quick things about a pie chart before we continue. For pie charts, we need everything to completely add up to 100%. It does need to be as a percentage, and it does need to add up to 100%. In addition, if you get too many categories, a pie chart would not be ideal since it would overwhelm the pie and it would be really hard to read it. The next thing we'll look at is a bar graph. So a bar graph uses bars to denote the frequency or the height, that count. So in general, we have two axes, the x and the y. On the x-axis, down at the bottom, we would put our categories. So I'm going to go ahead and abbreviate these with B for blue, R for red, Y for yellow, and O for orange. And then the frequencies go on the y-axis. We then draw bars to denote the height or the count. So we had 5 blues. So we'll draw up to 5 and back down. For red, we had 4. Yellow had 3. And orange had 4. A couple of quick notes about this. One, a bar graph, the bars can actually be vertical or horizontal. So I put my colors on the x-axis and my frequency on the y, but you can absolutely switch those with no issues. The other big note is in a bar graph, the bars should absolutely not touch. We don't want the bars in a bar graph to touch. That would indicate that there's some continuity between the classes on the x-axis, but in a bar graph there's not. So the general rule is for bars to never touch on a bar graph.